Imagine looking up at the night sky, wondering if we're alone. For the first time, we might have an answer. Scientists at NASA, using our most powerful telescope, have detected something extraordinary. A chemical clue from a planet orbiting a distant star. This isn't science fiction. It's real, unfolding right now. The planet is called K2-18b, a world we can't visit, but can study from afar. By analyzing the light passing through its atmosphere, we've found the signature of a gas that, on Earth, is only produced by life. It's a fragile thread of evidence, but it connects our world to a vast universe of possibilities. If this discovery is confirmed, it means the story of life isn't just ours. Somewhere out there, under a different sun, another story could be unfolding. This isn't just about finding a new planet. It's about finding a new beginning. So let's journey across 120 light-years to a world that could rewrite our textbooks. We'll explore what makes K2-18b special, the strange signs in its sky, and how our telescopes reveal these cosmic secrets. The universe is speaking. Are we ready to listen? K2-18b orbits a cool red dwarf star in the constellation Leo, 120 light-years away, far beyond our reach. We study it by analyzing faint starlight, becoming cosmic detectives. K2-18b is a Hycean world, bigger than Earth, smaller than Neptune. Its orbit places it in the habitable zone, the Goldilocks Zone, not too hot, not too cold, just right for liquid water. Imagine a planet covered by vast oceans, a true water world. On Earth, wherever there's water, there's life, even in the most extreme places. If K2-18b has a liquid ocean, it could be a stable environment for life to begin. But water isn't enough. A planet needs an atmosphere. K2-18b has one, acting as a protective blanket and stabilizing temperatures. Our telescopes have found the most exciting clues within this atmosphere. The combination of water, atmosphere, and the right temperature makes K2-18b a prime candidate in our search for life. It checks all the right boxes, inviting us to look closer. What secrets might it hold? Studying a planet's atmosphere is like analyzing its breath. Using the James Webb Space Telescope, scientists found carbon dioxide and methane in K2-18b's atmosphere. Building blocks for life, but not proof. Then came a game changer, a possible hint of dimethyl sulfide or DMS. On Earth, DMS is only produced by living things, tiny marine organisms. No known geological process creates DMS in significant amounts. Finding even a trace in K2-18b's atmosphere is a profound hint of biology. This is what scientists call a biosignature, a chemical fingerprint of life. The detection is still preliminary and needs confirmation, but for now, it's the most compelling evidence we've ever found for life beyond Earth. The breath of K2-18b may carry the scent of a distant ocean. If DMS is real and produced by life, what could it be? Imagine a global ocean teeming with microscopic organisms like Earth's phytoplankton, floating in the sunlit waters and releasing DMS. Perhaps there are even more complex forms, bioluminescent creatures or alien kelp forests. Life on K2-18b would be shaped by its unique environment, evolving in ways we can only imagine. Maybe the universe is filled with worlds like this, alive but with simple microbial life. Intelligent life could be rare, but microbial life might be common. The discovery on K2-18b suggests the universe isn't silent. We just needed the right tools to listen. If true, the cosmos is a garden of living worlds. How do we detect the breath of a planet trillions of miles away? With the James Webb Space Telescope, JWS sees the universe in infrared light, heat radiation invisible to our eyes. When K2-18b passes in front of its star, starlight filters through its atmosphere. Different gases absorb specific wavelengths, creating a chemical barcode. JWS analyzes which colors are missing, revealing the gases present. This is a leap beyond older telescopes like Hubble, which couldn't see these faint chemical signatures. JWST's massive mirror and ultra-cold sensors make it exquisitely sensitive. It turns distant planets from points of light into real worlds with weather, chemistry, and maybe biology. It's not just a bigger telescope, it's a revolutionary tool opening a new window on the universe. With JWST, we're finally able to search for life's fingerprints across the cosmos. JWST's glimpse of K2-18b is just the beginning. Scientists will keep observing, testing, and confirming the DMS signal. But even JWST has limits. It can't take direct pictures of distant planets. The next generation of telescopes, like the extremely large telescope in Chile, will see exoplanets in unprecedented detail. Future missions, like NASA's planned Habitable Worlds Observatory, aim to find and study dozens of Earth-like planets. These telescopes will search for multiple biosignatures, not just one. Each new mission brings us closer to answering the question, are we alone? The search that began with Galileo now extends to worlds orbiting other stars. The age of exoplanet exploration is just beginning. What if we confirm life on K2-18b? The impact would be staggering. It would transform biology into a universal science, revealing the fundamental rules of life. It would challenge our philosophies, religions, and sense of uniqueness. For some, it would be a spiritual revelation. For others, a humbling reminder of our place in the cosmos. Discovering life elsewhere could inspire us to protect our own planet, seeing Earth as one of many living worlds. The overview effect, seeing Earth from space, could become a shared experience for all humanity. The search for life is about more than data, it's about meaning. The hint of life on K2-18b reminds us that the universe is full of wonder. Whether this clue leads to confirmation or not, the quest continues. We keep looking, building, and asking that ancient question, because the search for life is ultimately a search for ourselves.